everyone, welcome back to Drill Coding, and in this video we are going to cover some of the most frequently asked Java interview questions. So let's get started. Encapsulation means hiding data and controlling how it is modified. Making fields private is only the first step. If public setters allow setting any value, the object loses control over its state. Invalid or inconsistent data can be set from outside the class. This breaks the idea of protecting internal behavior. True encapsulation requires validation or restricted access, and in some cases, setters should not be exposed at all. So, private fields with unrestricted setters are not fully encapsulated. What is the difference between an object and an object reference in Java? Object and object reference are not the same. An object is the real data created in heap memory using the new keyword. An object reference is a variable that stores the address of that object. The reference is stored in stack memory. Multiple references can point to the same object, and changing the object through one reference affects all the references, and references are used to access objects, not store them. And in this example, S is the reference and object is stored in the heap. What is the Java memory model and why is it important? Java memory model defines how threads interact with memory. It specifies rules for visibility, ordering, and atomicity of variables. And without JMM, threads may see inconsistent data. One thread's changes may not be visible to another thread. JMM ensures predictable behavior in multi-threaded programs. It explains how volatile and synchronized work internally. JMM is essential for writing correct concurrent code. What is the difference between volatile and atomic integer? Volatile ensures visibility of variable changes across threads. It does not guarantee atomic operations. Operations like increment are not thread safe with volatile. Atomic integer provides both visibility and atomicity. It uses lock-free, low-level CPU instructions. Volatile used for flags or status variables. Atomic integer is used for counters and shared numeric data. And this is the example. Now, fifth question is, how does Java achieve thread safety internally? Java provides multiple mechanisms to achieve thread safety. The synchronized keyword ensures mutual exclusion. Locks like rintrent lock provide advanced locking control. Immutable objects are inherently thread safe. Atomic classes support lock-free thread safety. The Java memory model ensures proper visibility of data, and thread safety depends on correct usage of these tools. How does JVM decide whether an object is eligible for garbage collection? JVM uses reachability to decide garbage collection. If an object is not reachable for any GC route, it becomes eligible. GC routes include local variables, static variables, and active threads. Unreachable objects are considered garbage. Eligibility does not mean immediate deletion. Actual cleanup depends on the garbage collector, and this process helps reclaim unused heap memory. What are memory leaks in Java and how can they happen even with garbage collection? A memory leak occurs when objects are not released even when unused. Garbage collector cannot collect reachable objects. Unnecessary references prevent objects from being freed. Common causes include static references and improper collections usage. Listeners not removed can also cause memory leaks. GC works correctly, but references block cleanup, and this leads to increased memory usage over time. How does Java handle method calls internally? Java uses a stack memory to handle method calls. Each method call creates a stack frame. Stack frame stores local variables and method parameters. It also stores return address information. When method execution completes, its stack frame is removed. This follows last in, first out order. Stack-based execution ensures fast method invocation. Now, why is the main method static in Java? The main method is the entry point of a Java program. JVM needs to call main method without creating an object. Static methods belong to the class, not an instance. And making main method static avoids unnecessary object creation. JVM can directly invoke it using class name. This ensures program execution starts smoothly. That's why main method must be static. Why is a string immutable in Java and how does it help in multi-threading? String objects cannot be modified once created. Immutability ensures thread safety without synchronization. Multiple threads can safely share the same string object. It prevents accidental data modification. Immutability also helps in string pool optimization. Security is improved because data cannot be changed, and this design improves performance and reliability. That's all for today's video. If you found this video helpful, don't forget to like, share and subscribe. See you in the next video. Till then, keep learning, keep coding.